We are walking along the beach west of the Cobb in Lyme Regis in Dorset, past cliffs formed during the Jurassic period, around 200 million years ago. We are now in front of the cliffs of the Lower Lias, where you find one of the most famous invertebrate fossils that there is, the devil's toenail, Gryphaea arcuata. So, what are Gryphaea? They're bivalves with two shells. In many ways, they're like present-day oysters, but unlike them, they were never fixed to a solid surface. They rested on the fine mud. This is called reclining. We think that they sat still because their muscles were probably not strong enough to open and close their shells to make them move. So, where are they from? Gryphaea are found in the Lower Lias rock in Dorset, and in fact throughout Europe. Our fossils have come from soft shale layers in between the hard limestone bands seen on the cliff. They can also be found cemented in limestone. They lived at the very start of the Jurassic period, around 200 million years ago, at a time when this area was a shallow, warm tropical sea. So why did Gryphaea die out? There are many possible reasons for this. They include biological defects, predators and competition. Our guess is as good as yours. So, Ross, why are Gryphaea so interesting?
We're very lucky in southern Dorset, is that we have a lot of magnificent coastline with an enormous number of very famous vertebrate fossils. Mary Anning in the 19th century found the ichthyosaurs and the plesiosaurs, and now the Scelidosaurus. There's a range of really important vertebrate fossils, but actually at the bottom of the Lias, west of Lyme Regis, we have a very, very important invertebrate fossil called Gryphaea arcuata, better known as the devil's toenail. This is an extraordinary little fossil. It started as an ostrea. It was fixed to rocks in these littoral warm seas of the Jurassic, and it ended up recumbent in the mud, not attached to anything. And it's this evolution, because the fossils are very abundant, the change in the shape of the shell as it changed from being fixed to being recumbent in the mud is very, very easy to demonstrate. And in 1922, a geologist called Truman studied this in detail and wrote an important paper showing how this fossil evolved. And with 2009 being the 200th anniversary of the birth of another geologist, Charles Darwin, it's really important to look and focus on this fossil that shows us very clearly how evolution took place. And this is a really, really important fossil.